Let's take inventory of how we can integrate using a little integration checklist. Now, don't forget that we have basic integration. Of course, basic integration is when you really just have one function, and using a rule, you can find its antiderivative. Of course, who can forget that we have substitution? Substitution is, you'll learn, one of the main ways to integrate, but it only works if you have a function that has that du cancellation connection. There are some other functions where we seem to not have a connection, but there still should be a way to integrate, and there is. It's using something known as parts, which is actually the product rule backwards. Now, if we're going to do the product rule backwards, maybe we should do the product rule forwards. So you want to take a look at the derivative of uv. Remember how we learned how to do the product rule? Now this is the derivative from the first half of the year, which of course it would be the derivative of the, it would be the first times the derivative of the second plus the second times the derivative of the first. Now, if we want to do this backwards, then I just need to throw an integral sign at this, so to speak, formula. And you're allowed to do that. You're just going to do the integral of the whole equation. It turns out that calculus would say that there's some cancellation happens here. It's actually these dx's that are going to cancel. So once they all cancel and we kind of clean it up, we end up with this statement. Now, this might get a little confusing, but just make sure you realize we started with the product rule, and now we're trying to do the product rule backwards, which is basically undoing what we did. But we have these integral signs, and it turns out if I do a little bit of rearranging, that is, if I subtract this integral to the other side, well, we're going to get a special result. So let's subtract the integral of v du, and sounds kind of like it's a horse. And once it gets itself parked over there, we actually end up with a formula. It's a formula that you're going to get to know as the parts formula. And the parts formula says that the integral of u dv is equal to uv minus the integral of v du. Now that sounds and looks like something that's quite confusing, but you'll find out that it's actually easier than a substitution method. And the reason it's easier is because, quite frankly, it's a formula. And what do you do with formulas? You plug into them. And when you plug into them correctly, you get the integral. And that's sometimes what students forget. They forget that when you plug into this formula, you actually get the answer. But what do all these symbols mean? Well, first of all, it's going to be the integral of u dv, which are the two parts. One of them is going to be a function u, and one of them is going to be a function dv. How do we know which one's which? Well, the u function gets assigned using something called the Lipid Test. Now, the Lipid Test is just an acronym for assigning a math function to be u. Can you think of a popular math function that starts with an L? A math function that starts with an L. Did you say log? Well, if you did, you'd be correct. How about a math function that starts with an I? An I. Inverse. Inverse trig. Now, I'll let you know what's happening here is that if you have a log in your equation, it's going to be u. But if you don't have a log, then maybe you'll have an inverse trig. If you have an inverse trig, then that one would become u. What if you have both? Well, this is like a hierarchy. So logs always come first, and then comes inverse, and then comes trig function that starts with a p. P for power function. But if you don't have a power function, then maybe you have an e. An e for exponential. But if you don't have an e, well, then maybe you have a t for trig function. So again, this is a hierarchy, and whatever function you have, or whichever one comes first in this list, will be the one that you assign to u. I'll show you. How about dv? dv can seem a little intimidating because it's like a calculus variable. You're going to find out that dv is actually another function. And if you do it right, it's going to have to be something that's easy to integrate. Of course, if you also do it right, you would have already figured out what u equals. So you'll find out that to start this problem, the first thing we need to do is just assign u and dv. Once we assign u and dv, we're just going to throw them into the formula. And what's the formula? It's uv minus the integral of v du. Let's try it for an actual integral. So we have here the integral of x to the fourth times the ln of x dx. There's definitely two parts. Really, the two parts are the two functions that are being multiplied together. So we want to get to the business of assigning u. Now, we just got to use a Lipid test. So first comes log. Do we have any logs? Well, yes, we do. We have the ln of x. So it's kind of an easy start. We're just going to let u equal the ln of x, again, based on the Lipid test. Now, you'll find that we also need to assign dv. So we'll go ahead and do that right now, because dv ends up really just being the rest of the problem. Technically, the rest of the problem is x to the fourth dx. As you'll find out in a second, that's something that we can integrate. Now, the reason we want to integrate it is because we're really making what I like to call like a little box of variables. This little box of variables is missing some other pieces. It's missing du. So how do we find du? Well, that's just the derivative of ln. So that's going to end up being 1 over x dx. But we're also missing in the box, we're missing v. And here's the part that you want to be careful. I'm now going the other direction. I'm now doing the antiderivative. So we end up also finding the value of v, which is going to require us to add to the exponent and divide by the new exponent. Just a basic antiderivative, of course, x 1/5, x to the fifth. Oop. Now, the reason that we found this little box of variables is because we want to plug into the formula. You see, the formula says take u times v. So u times v, I got my box of variables. That's just going to be ln times 1/5 x to the fifth. We typically write that with the power function first, although it really doesn't matter. We're going to go ahead and write as 1/5 x to the fifth ln of x. Look at the rest of the formula. The rest of the formula says to subtract the integral of v du. So I've got v and I've got du. I'm going to go ahead and put those into the formula as 1/5 x to the fifth times 1 over x dx. Now, the part that you're going to want to begin to understand here is that we still have some work to do. We plugged into the formula. The formula is the answer, but the formula tells us to actually do an integral. Right here, we have to do the integral of 1/5 x to the fifth over 1 over x. Well, for starters, that can be simplified to be x to the fourth. But still, I need to actually do this integral. And that's kind of the part that sometimes students miss. The formula still requires you to do calculus. So what's the integral of 1/5 x to the fourth? Once again, you add to the exponent and you divide by the new exponent. That's a little clunky because we're already dividing by 5. So what we're actually going to do is we're going to just put another 5 in the denominator. And that'll leave us with 1 over 20 x to the fifth. Of course, don't forget the other part of the formula, the other part of your answer is just tagging along here. And we end up with a final answer of 1/5 x to the fifth ln of x minus 1 over 20 x to the fifth plus c. Okay, and that's going to be the integral, of course, or antiderivative of our original problem. Let's try another one. A lot of this is using a formula to find an integral, but we do want to use the formula correctly. We got x e to the negative x. Again, it's a classic parts problem because there's basically two functions here that are being multiplied together. What we want to do is get to the business of assigning u. Now, assigning u is the Lipid test, which is nice. You just basically have to figure out, is there a log? No. Is there an inverse trig? No. Is there a power function? Yes. Okay, this is one you got to be careful about. The x right here, that is a power function, so that counts as u according to the Lipid test. Now, we also want to assign dv. dv is going to be the rest of the problem. It's also going to end up being a function that we can integrate. It's e to the negative x dx. We need this box of variables, so do the derivative of x. It's just dx. Okay, you don't need to mess with the number 1. We also need to do the antiderivative to go back this direction. Now, the antiderivative of e to the negative x, it's the same thing. It's e to the negative x divided by k. Now, k is the number in front of x. It's -1. So when we divide by k, we get -1. Plug it into the formula. uv minus, so here comes uv. It's just going to be x times negative e to the negative x. Now, I hesitate a little bit there because I don't like to put that negative sign in that spot. We're just going to put the negative sign in front of the entire uv. Okay, but that's just the multiplication of our two variables minus the integral of v du. Well, v is negative e to the negative x, negative e to the negative x dx. Okay, now there's a lot of negative signs in this problem. We definitely have the negative sign that's in front of the x e to the negative x, but we also have these two negative signs that might as well cancel and become positive. I always encourage you to do algebra before calculus. In other words, before we actually do the antiderivative. But you have to do the antiderivative. You have to actually do the integral, the antiderivative of e to the negative x. Well, that's, of course, going to come out to be negative e to the negative x, okay, because I basically divide by k. But this negative x e to the negative x, that's still part of my answer. And don't forget the plus c. Okay, now we are doing the product rule backwards. If I decided to, I could do the product rule forwards, and you would see that I go back to the original problem. I'm not going to spend the time checking that right now, but just to kind of keep in mind that's the forward backwards of these problems. If we were in class, this would be a problem that I would say, why don't you try it? So we're still learning, and I'm going to say, why don't you try it? See if you can set up u using the Lipid test. See if you can find your box of variables. And then can you put them all in the formula and get a final answer? Okay, is there a log? No. Is there an inverse trig? No. Is there a power function? Yes, it's x again. dv ends up being the rest of the problem, cosine times dx. Derivative of x is basically the derivative of x. It's a dx. Remember, for dv to turn back into v, you actually are doing the antiderivative. You're going back up to that. Antiderivative of cosine is sine. uv is x sine x minus the integral of v du. Sometimes students feel like that they kind of going in circles, but you're not. You're just working through the formula. Believe me, we'll do a problem next week that's going to feel like you're going in circles. So in other words, you want to do the integral of sine. The integral of sine. So that's the antiderivative of sine. Okay, that should be coming out to be an opposite cosine. Let's make sure that we're careful that we keep the minus sign that's in the formula and get an opposite sign based on the rule. Of course, now we have two negatives. And we'll end up with x sine plus cosine plus c. There's got to be something special that's in store for x squared sine of x. So if I hadn't told you that there was something special in store for this problem, would we have been able to just proceed as normal with the lipid test? Yeah. In fact, that's still what we're going to do. Just a little surprise that's coming down the road. Now, the lipid test says that you would have to assign u to be a power. It's kind of the first one that we see on the list. So, of course, u equals x squared. dv is just going to be the rest of the problem. Looks like all we have left is a sine dx. Still need the derivative of x squared. That's 2x dx. And the antiderivative is going to get you v. Remember, you're going back to the antiderivative, and that should be an opposite cosine. All right, well, let's start the rule. The rule starts with a uv. That's x squared times negative cosine. I'm going to go ahead and just put the negative sign in front of the x squared. So there's our uv. There's always a minus the integral of v. Now v is negative cosine du. I'm going to go ahead, though, and put this du, in other words, the 2x, I'm going to put that first. I still have the negative sign that came with the cosine, and then dx. Now, I'm always a fan of doing algebra before calculus. Honestly, these two negative signs right here will become a plus a positive. Might as well, right? All right, so we have negative x squared cosine of x, kind of done with that. But now we're staring at this integral of 2x cosine x. How do you do the integral of 2x cosine of x? How do you do that? Is it just another basic? Can't be. There's two functions there. And those two functions represent two parts. That's right. What that means is that we need to do another lipid test. Now, I'm going to go ahead and erase that. I got a little carried away. Let's do the lipid test on this red integral. Let's basically do another parts formula. Okay, now another parts formula is going to give us another u and another dv. And let's see here. The antiderivative of cosine. That's just sine. I almost forgot the derivative of u over here. That's going to be a 2 dx. But the point is that the only way to do that red integral is to set up another parts formula. Now, you don't want to lose track of what you've already done, and that's my negative x squared cosine of x. But now, kind of sort of a new idea, I actually have to do another uv minus v du. So I have to do a 2x, that's uv, times sine, minus the integral of v du. Now, v, of course, is sine, but du is 2. Can I put that 2 first? Sure, I can. All right. What do we got here? Okay, well, we have another integral to do. This integral is In other words, the antiderivative of 2 sine of x. Can we just do that with a basic rule? Yeah, we can. Okay, because the integral of 2 sine, the 2 is just going to come down. You're going to end up with an opposite cosine. As we've said many times, we like to put that opposite in front. But the bottom line is I'm now able to kind of finish this integral. I just don't want to lose track of everything else that I've done. I still have this x squared, negative x squared cosine. I still have this 2x sine. And you'll find out for a lot of these problems, it's the negative signs that can get tricky, but I still have that negative sign. Now the red negative and the blue negative, they become a plus plus. And I think I have my integral. Okay, it required us to do the parts rule twice. All right, we will surely be revisiting some more problems like that next time that we're together. We'll see you then.